Greetings, my wonderful scholars. It's nice to have you on today's class. Our topic of discussion today is concept of density. But before we delve into the topic, I'd love to ask you a few questions. Why do you think the game of soccer, football, comes in categories, feeder team and senior team? Why is the game short put, played one person per time, and the game of soccer, we have 22 players on the field? And so many other questions. The concept of density will provide answers to these questions. Why the game of soccer has 22 players on the field and the game of shot put has one player playing at a time. And in boxing, we have categories. In football, we have categories. Feeder team for junior players and senior team. Density has answers to these questions. But before then, my wonderful scholars, I would love to remind you our discussion on physical quantities. Physical quantities. Every matter has various properties in it that can be measured by scientists to come up with what happens within every matter or how a matter behaves. Those properties that will measure a matter to explain what happens in the matter, those properties are termed physical quantities because they can be measured, quantized. One of the physical quantities is our interest today. Density, a derived quantity. Density is a derived quantity. What is density? But before we define density, let's demystify the nature or the idea behind density. We'll go back to our initial questions. In the game of soccer, we have diverse levels of playing. We have feeder team, senior team, and so on. What's the difference? The difference is density. In the bone, the density of our bone is not the same. The density of the bone of a boy is not the same as that of a man. Density deals with the arrangement of particles in a body. Recall, mass is defined as the number of particles in a body. The more particles in a body, the more the mass. The less particles in a body, the less the mass. Or mass is the number of atoms in a body. The more atoms a body have, the massive the body is. The less atoms in a body, the less massive the body is. Then when we talk about the arrangements of these tiny particles or these small particles in a body, we are talking of density, the arrangements. Before I will continue with that of football, let me go back to shot put and football as equipment in games. A football, even though it appears bigger than a shot put, is less dense compared to a shot put. In other words, shot put is denser than a football. Why? Because shot put has more particles, has more congealed particles. And that's what we call this, the arrangement of particles. Density makes space for more particles to be accumulated, and are highly compressed. The particles are highly compressed. So anything that is denser must have more particles. The arrangement of the particles will be in a way or in a manner that more particles will be what? Gathered. And that brings about compression. So the particles are highly compressed, thereby increasing the density. Whereas in football, is filled with air, which gives it that spherical shape. But shot put is not filled with air. Every portion of shot put has particle in it, has solid particle in it. So shot put contains more particles compared to a football, even though a football appears to have a greater volume, but it's less dense compared to what? Shot put. This is why nobody dares to hit shot put or to not shot put the way we not football. When you not shot put the same way we not football, you get the clearer difference that we're trying to portray. That anything that must be dense must contain more particles in a way that it will accumulate particles in empty spaces like a shot put. But a football has a kind of empty space inside, a space that is filled up with air. I know the particles of air are highly spaced out. They are highly spaced out. But shot put, the particles are highly what? Compressed. So the idea of density is the idea of arrangement of particles inside a body. You arrange particles in a way that every tiny space will be occupied by a particle. And this is what you see in a shot put. And this is why the game of soccer has levels. There is soccer for boys and soccer for men, because our bones don't have the same density. The bone of a boy is not the same as the bone of a man. A boy of 12 years cannot play a football match against a man of 25, 27, or 30 years, because the bone densities are not the same. When there is a kind of collision, football is a game of contact. If there is collision between two bones, the bone of a boy can get broken or fractured. Density. This is why we have categories in game for safety reasons. The concept of density. So a shot put is denser than a football, irrespective of the bigger volume or size of a football. This is why in the game of shot put is done one player at a go, one player at a time. Unlike football that all players or most of the players go for football, go for ball, the chest, the nod. You can't do that. You can't try that with a shot put, because a shot put has a greater density. The idea of density, very, very important. The arrangement of particles in a way that every space is targeted to be occupied by a particle. So denser bodies accumulate more particles, while less dense bodies are highly spaced out, accumulating less particles. Recall, anytime we do science logic, we try our best to portray it in mathematical equation to simplify the nature of that concept. So that will take us to the formula for finding density. But before we derive that, recall, I've once communicated the idea of inverse proportional variation, indirect proportional variation, where we have two variables or more. Okay, let's start with two. We have two variables. When one variable goes up, the other comes down. And when the one that is down begins to go up, the one that was up begins to do what? Come down. They can never go in the same pattern or level. Inverse proportion. Inverse proportion. The same is the nature of density as we portray on the board. You can't talk of density in the absence of these two other physical quantities. Volume, mass. The idea of density comprises of mass and volume. Okay, let's go mathematical. We say that V, M, density. Let's go for D. D is inversely proportional to volume. Density is inversely proportional to volume. What do we mean by that? Very simple idea. We are saying that the denser a body, the smaller the volume. The denser a body becomes, the smaller its volume. Let me give you a clearer example again. When you get bread, yeah, like boarding school bread, small size bread, when you get it, observe the initial volume. Observe the initial volume. Yeah, it's big. With respect to the emphasis I want to make, it's big. The initial volume is big. Then its density is small. When volume increases, density reduces. Then see what most students will do. If it happens to be a boarding school where you normally see bread and tea as breakfast, most students will get the bread and do what? Compress it. When they compress the bread, they've done something unique. They've increased the density of the bread, thereby lowering its volume. A compressed bread will pack the particles inside. Those tiny spaces in the bread now be covered by the particles of the flour that makes up the bread, or the bread itself. The particles will now cover those tiny spaces, and the volume will do what? Lower or reduce. Compressed bread, higher density, lower volume. But the initial condition, higher volume, lower density. This is why when a student stones another student with the initial form of the bread, where the volume is high and density is less, the student feels like nothing made contact with him. The pain can be endured. But when another student compresses his own bread, takes into a tiny form and stones someone with it, the difference is clear. Because the density of the bread has done what? Increased, whereas the volume did what? Reduce. This is what we want to portray mathematically. That higher density means lower volume. But lower density implies higher volume. This law of nature. Okay, then observe the bread you had at the starting and the one that you compressed. The number of particles are intact. What you vary there is the arrangement. You did not add bread. You did not remove bread. It's the same bread. Probably it was enclosed in a sachet. So all you've done is that you made the particles to cover tiny spaces, compression. You did not add bread, you did not remove. So the number of particles in the bread is constant. Recall, every variation must have constants. So the number of particles, 10 max, is constant. No bread was added, no bread was removed. We only altered the arrangement. Therefore, we can go back to say density is equal to, we want to take away this variation sign. Anytime we take away variation sign, we introduce equal to and a constant. K. K times 1 is K over volume. We are getting close to the final formula for finding density. Then recall, the variables here are density and volume. These are things that will change. We compress the bread, the density increased and the volume lowered. So the mass is constant. So we can now take away K and put in mass. Therefore, the new formula becomes D is equal to M over V. A very unique formula. In physics, in science as a whole, we don't cram formulas, we understand the formula. It's logical, it's what happens every day. So the higher the density, the lower the volume. The higher the volume, the lower the density. But the mass remains constant. The mass does not change. That's a beautiful equation on the board. The mass doesn't change. The number of particles in your bread is the same. But your bread now, at in one form is doing wonders, in the other form is salt. This is the idea of density. Recall, why we have levels in sports is because of density. Difference in bone density. Why shot put is played one player at a time, density. Why football can accumulate more number of players, density. Less density. This is the idea of density. A very unique idea. So if truly you've understood the idea of density, help me to answer this puzzle. If I have 1000 kg of hammer and 1000 kg of peppers, 1000 kg of paper, which one weighs more than the other? Paying attention. When we have 1000 kg of paper against 1000 kg of hammer, which weighs more than the other? Which one has a greater mass? Okay, let me hear from you. 1000 kg of paper and 1000 kg of hammer. Which one weighs more than the other? Okay, this puzzle is a very smart one to test your extent of mastery of the concept of density. The answer is none. None weighs more than the other. None weighs more than the other. See, in science, measurements, you have to pay keen attention to it. Let's see the measurements. The measurement here is 1000 kg, 1000 kg. They have the same measurements. 1000 kg. Therefore, none weighs more than the other. But see why you had challenge in answering this question. The challenge is as a result of the concept of density. If hammer would weigh 1000 kg and pepper 1000 kg, the volume will not be the same. The volume will not be the same. Yeah, the mass is constant. The mass is constant. The volume and the density will not be the same. Okay, observe the board. The hammer will assume a smaller volume, while the peppers will assume the biggest volume. It will take, for example, one hammer to make 1000 kg and take like millions of particles of paper in a basket to get equivalent mass. So one hammer will give us, for example, making instance here, one hammer can be 1000 kg, but to take excess number of papers in a basket to give us equivalent what? Mass. So don't be confused. The mass is the same because we have one hammer versus millions or trillions of papers in a basket to get commensurate measurements. So here we have a greater volume. Here we have a smaller volume to make up for that 1000 kg that is the same in them. The idea of density. In the basket of paper, we keep on packing papers. We are compressing it, getting more particles. The particles of the number of particles in this paper, it will take more number of particles in the paper to get equivalent number of particles in the hammer, because they are made of different substances. Hammer is made of a very heavy substance, iron or steel, while paper is made of a very light substance, carbon, light substance, or pulp from trees. So to get a commensurate effect or the same effect in terms of mass, we have more particles of paper or baskets of paper to get equivalent mass with hammer. So for the fact to say the 1000 kg, they are the same. The only difference here is the volume. And we say to get the density of a body, we say, or we use the mathematical equation, mass over volume. Therefore, density can still be defined as the ratio of mass to volume. Density, therefore, can be defined as the ratio of mass to volume. The higher the density, the lower the volume. The higher the volume, the lower the density. So if you have any intention to increase the density of a body, what do? You congeal it, you compress it. What are you trying to do? To lower the volume. For every lowered volume, there is increase in density. But for every increased volume, there is decrease in density. Inverse proportion. Inverse proportion. Okay, we have different categories or kinds of density. We have relative density. We have charge density. We have vapor density. So paying attention, let's differentiate these three kinds of density. When we use the word relative density, recall, relative means you are trying to compare. When I say I am your relative, I mean that there is a connection between, there is something that links us together. There is something that bonds us together. Relative. For you to make comparison, there must be something shared in common. Maybe blood, maybe marriage, maybe friendship. Relative. Something is shared in common. Relative density. This time you compare two things. In relative density, we compare two substances. One may be solid and the other liquid. Or you compare two liquids. In relative density, we form a ratio. We have a numerator over denominator. For instance, we have a common denominator in relative density. Anytime we talk about relative density, we use water as a common denominator, density of water. Here we compare two densities. So relative density of solid is density of a particular solid over density of water. Relative density of solid is density of a particular solid over density of water, or divided by density of water. We use water as a common denominator because water is a universal solvent. Take for instance, if engineers want to know a material that can float on water, you check the relative density of that material, be it solid or liquid. For instance, I want to develop ship. I have option of diverse materials to use. So for any material we use, I will check its relative density. I will get that solid, keep on water, immerse it in water, and notice if the body floats or sinks. Anybody that sinks in water is denser than water. But anybody that floats on water is less dense compared to what? Water. Water is denser than it. So this is why we do relative density, and we have a common denominator, which is what? Water. So relative density of solid is density of a solid or that solid divided by density of water. But the water must have equal volume with the solid. We ensure that the two substances have equal volume. The density of the solid over the density of water. Likewise, relative density of liquids. Density of the liquid over density of water. Water is always a common denominator, be it solid or liquid. But do not forget, they must have equal volume. If you've noticed, oil floats on water. So to get the relative density of oil, it will be equal to density of oil over density of water. And because oil floats on water, it will have a number less than 1. Because 1 in relative density would imply that both substances have the same density. When the same number form a ratio, they'll give us 1. 2 over 2, 1. 3 over 3, 1. 10 over 10, 1. So any substance that has relative density of 1 has equal density, has the same density as water if the same volume is considered. But anything that has relative density less than 1 is less dense. That thing can float on water. It's less dense compared to water. Any object, any material, any substance, be it solid or liquid, that has relative density greater than 1, that thing sinks in water because it's denser than water. This is the idea of relative density, comparison. And the common denominator is density of water. Okay. Under relative density, RD, relative density of solid is density of that solid over density of water. Then, if it happens to be liquid, substitute solid with liquid. Density of alcohol over density of water. That's relative density of alcohol. Density of oil over density of water. Relative density of oil. And recall, if we have the same physical quantity as numerator and denominator, the units will cancel. Relative density has no units. And that reminds me, let's go back to derive the units of density. If density is mass over volume, if density is equated as mass over volume, ask yourself, what is the SI unit of mass? Kilogram. The formula says divided by per. What's the SI unit of volume? Meter cube. Therefore, the SI unit for finding density is kilogram per meter cube, which can also be deduced as kilogram per meter cube. Kg for mass, per for over, MQ for volume. We can also have other units like gram per centimeter cube. Mass can also be measured in gram. Volume can also be measured in centimeter cube. So density can as well be measured as gram per cm cube, gram per centimeter cube. But the most appropriate units is kilogram per meter cube. In our subsequent videos, I will teach you how to make conversion. So do not panic. Conversion is one of the easiest things you can do in physics. In our future course, we'll discuss how to convert from one unit to another unit. Just note that the units of density can either be gram per cm cube or kilogram per meter cube. Okay, let's go to the second category. Vapor density. Vapor density. Vapor density is similar to relative density. Here we form a ratio again. We compare density of any gas or vapor to density of hydrogen. Sometimes density of oxygen, sometimes density of air. But the most used denominator is density of hydrogen. If I get density of one gas, for example, carbon dioxide, density of carbon dioxide divided by density of hydrogen, that's what we call vapor density. Vapor density. It makes comparison, just like relative density. Density of any gas or vapor over density of hydrogen. That's what we call vapor density. Density of CO2 divided by density of hydrogen. Density of hydrogen. Okay, vapor density. Recall, vapor density is the density of gas of vapor over density of hydrogen. Relative density is density of solid or liquid over equal volume of density of water. Then the last density that we'll be discussing today is charge density. This is seen in the electrical world. In charge density, we'll replace the numerator with charge and we'll maintain the denominator. Charge density is charge divided by volume. Recall, density is mass over volume. This time, the mass now is being replaced with charge. Charge. That's why it's called charge density. Number of charge or quantity of charge divided by volume is what we call charge density in the electrical world. Charge density is equal to quantity of charge over volume. That's our charge density. Sometimes in the standard exam, you see charge over area. Do not panic. Do not panic. Recall, if we can have volume, we can also have area. Anytime we use area in place of volume, it is called surface charge density because a surface is 2 dimension, but volume is 3 dimension. So when we use the concept surface charge density, it becomes charge over what? Area. So be conscious of the fact that your charge density can either be charge over volume or charge over area. When it's charge over volume, we call it charge density. When it's charge over area, we call it surface charge density. And you can also derive the units for your charge density. Let's get to that. You ask yourself, what is the unit of charge? Charge is measured in coulombs, in honor of Charles Coulombs. Capital C, because it's someone's name. The formula says over per. What's the unit of volume? Meter cube. Therefore, the unit of measurement for charge density is coulombs per meter cube. Coulombs per meter cube, which can also be deduced as coulombs per meter cube. In summary, recall, mass deals with the number of particles in a body. Density deals with the arrangement of the particles in a body. A body that has a given number of particles can be made to change form in a manner that the particles will be compressed to cover tiny spaces within the matter, thereby increasing the density and lowering the volume. Therefore, anywhere density is increased, the volume is what? Lowered. But anywhere the particles are spaced out, it simply means the volume is increased. Therefore, density is what? Lowered. Higher density, lower volume. Higher volume, lower density. And that's what we have in our equation. D for density is equal to M over V, meaning that the mass there is constant. We have different kinds of density. Relative density that makes comparison of solids or liquids with respect to the density of water. It tells us what sinks and what floats on water. For something to float, it must be less than 1. For something to sink, is greater than 1. When we have relative density 1, it means that the density of the solid or liquid is the same as density of water. Vapor density, we make comparison. The ratio is the ratio of the density of gas or vapor to density of hydrogen. Charge density, the ratio of charge to volume. Surface charge density, the ratio of charge to area. To get the units, the same pattern, we have coulombs per meter square. I want to believe you now know why sports has categories. You now know why boxing comes in levels. You now know why football accumulates more number of players, but shot put takes 1 player at a time. Stay tuned, relax, as we make physics fun and interesting and didactic. Thank you so much and remain on this platform. Please do subscribe.